Hi there and welcome to Tech Life, a channel where I aim to review everything from selfie sticks to laptops to IDs for coding, video editing, software producing thumbnails, essentially anything tech related. If you are new to the channel, please consider subscribing. If you have anything that you think I should review, please let me know in the comments and I'll do my best to review that product. In this video, we'll be looking at interfaces. An interface is similar to an abstract class. However, unlike abstract classes, all methods of an interface are fully abstract, meaning that the bodies of all methods in an interface are empty. A class, as we know, can specify state and behavior. So here we can see a class called animal, and these instant variables define the state of this class, and then the methods of the class, things like make a noise, eat, sleep, roam, uh, define the behavior of a class. An abstract class is a restricted class that cannot be used to create objects, meaning that we can't instantiate an abstract class. So here we have an example of a class called animal. We've defined it as an abstract class, and it has two methods. The first method is called animal sound, and it's an abstract method. So we use the keyword abstract, and we can see that there's no code in the body of this method. So it's a totally abstract method. But also we have the second method. It's called sleep. And in this instance, we have not defined it as an abstract method. And so we put code within the body of the method. So even though the class is abstract, it can still contain non-abstract methods. And as I say, we cannot instantiate this animal class because it is an abstract class. So we can't do something like this. We can't say animal, my object equals new animal. This would throw an error. What we can do is have a class that implements that uses animal. So we can define a class called dog, and it implements this, or it inherits from animal, which is an abstract class. And then once we implement the animal abstract class, then we can call the methods that are contained within that class. So the animal sound method can be called. But when we do call an abstract method from an abstract class, then we do have to provide the implementation. We do have to provide the code um, for that method. So in this case, we've done a simple console.writeLine just to say that the typical animal sound of a dog could potentially be a woof sound. Interfaces only specify behavior and do not hold state. So this diagram here shows an interface called feline. There's no instant variable, so there's no state or state data associated to this interface, but it does have um, methods which are the behavior of the interface. So we've got two methods here. One is called groom and the other is hunt. An interface can define functions, so these are functions or methods. The members or these methods of an interface are implicitly abstract. so we don't explicitly have to define them as abstract. There are exceptions to this rule, but we're not going to really cover that in this beginner's tutorial. A class or a struct can implement more than one interface. In contrast, a class can only inherit from one single class. So this diagram shows two superclasses. One is called animal and one is called feline. And it also shows subclasses, one called cat and the other lion and tiger. And these subclasses are inheriting from animal. But this last subclass over here, tiger, is actually attempting to inherit from animal and feline. This in C# in .NET is not allowed. We can only inherit from one class, but we can inherit from more than one interface. It's a subtle difference, but it's a very important difference. So in C# we can only ever inherit from one class, but we can inherit or implement more than one or more interfaces. So how do we actually create an interface? We do so by simply using the keyword interface. We give our interface a name, and by convention we always precede the name of an interface with a capital I. The I signifies interface, obviously, and it allows us to easily identify interfaces in our code. This convention is not enforced by .NET or Visual Studio or C#, but it's something that programmers try to stick to. So if you do create an interface, make sure you precede the name of the interface with this capital I. Next up, we declare our methods, and we don't have to use the keyword abstract because all methods within an interface are implicitly abstract, and we don't provide any code within the body of an abstract method. So this iAnimal interface only has this one abstract method, and it's called animal sound. In order to use the interface that we've just created, we cannot instantiate it. We cannot say new and then the name of the interface. We have to have a class that implements that interface. So we've got this class called dog, and it implements this iAnimal interface that we just created. And because we are implementing this interface, we are entering into a contract saying that, okay, I agree to implement this interface, and I also agree to provide a definition, provide code for any methods this interface may have. And fortunately, we've only got one method, and we have to provide code for this method. If we go ahead and attempt to compile this code without putting any code or declaring any code for this method, then we will get an error. So quite often you'll hear programmers talk about interfaces being similar to contracts, and all that really means is that if you decide to implement, if one of your classes implements an interface, then you have to provide code for all the methods that interface may have, and if you don't, then C# will complain and throw an error. And the last part of this code simply instantiates the dog class. Once we've instantiated the dog class, then we can call the methods within that class, and so we are calling the animal sound method, which in turn is obviously a method that we declared in the interface. So you might be wondering why we use interfaces. There are a couple of good reasons. Interfaces are useful for allowing us to have greater abstraction within our code. It makes our code easier to write, and also it's much more flexible and reusable. Interfaces also make it possible for objects of different types to interact with each other as long as they implement the same interface. This is known as polymorphism, and we won't really be discussing polymorphism in this video or any future videos because it tends to be more of a advanced subject. So we'll just leave polymorphism to one side for now. So I think if we fire up Visual Studio quickly, we can code up a small example and show interfaces in action. Okay, let's fire up Visual Studio and create a small app. So we're going to create a new project. Click on new. We're going to give, it's going to be a console app. So we select the top tab and we click next. Here we can name our app. We're going to call it interfaces. Click next. Click create, and Visual Studio will create a small skeleton console application for us. Take a second or two. Next, as always, we get rid of program.cs. So right click delete, and then we go and add. I'm just letting Visual Studio catch up with itself. So just right click, we're going to add a new item, and it's going to be a .cs. But the first thing we're going to code up is the interface. So I'm going to name this. I'm going to name it Polygon. But using the convention that we use, most .NET programmers use, because we know it's an interface, we're going to precede the name of the file with the capital I. So if I go ahead and add that, okay, Visual Studio is clever enough to know that I want an interface as opposed to a class. So we've used a keyword interface. We've named our interface Polygon, and we preceded the name with a capital I. I'm just going to clean this code up a little bit because we don't need all this stuff up here. So we don't need collections. We won't be using link, and there's not going to be threading in this application. So I think system and text should be fine. Okay, cool. So the next thing we need to do is declare or define a method. And I'm just going to put comment in here. A method without, oh, let me spell that correctly, without a body. So we're going to declare a method, but we're not going to put any code in the body. So it's going to be void, and it's going to be called calculate area. And we're going to pass in a couple of parameters. So both of them are going to be integers. One is going to be called length, and the second one is going to be called width. And we use a semicolon at the end of this. So that's our very first interface created in C#. Let's go ahead and save this. Okay, we've got an interface. We cannot instantiate this. We have to implement this within another class. So the next thing we do is a right click on interfaces. We do add again, a new item, and this time we're going to add a class, and we're going to call this class, I'm going to call it rectangle. Okay, so this is a class now. Okay, again, I'm going to clean this up. So I don't need those two. I'm not going to use that. Cool. So the namespace is interfaces, but we have created a class. Okay, and in order to use our iPolygon interface, we have to implement it within a class. And so the rectangle class is going to implement using the semicolon iPolygon. Okay. And the reason we've got the squiggly line, it's saying interface polygon rectangle does not implement interface member calculate area. So Visual Studio is complaining already, saying you've implemented an interface, and the contract for interfaces is that if you implement the interface, you have to use all its members. You have to provide code for every member within that interface. We only have one member in iPolygon, which is the calculate area. So in order to make Visual Studio happy, we have to provide code for that calculate area method. And in order to do that, we are going to put in a comment first, and I'm just going to say implementation of methods inside interface. So I'm going to implement all the methods that are associated to that iPolygon interface. Luckily there's only one, so this should not take long. So it's a public. It's not going to return anything, so it's void, and it's called calculate area. We know it takes two parameters, so they are length and width. And this is where we provide the code for the body of the method that we have declared in the interface, and it's going to be simple. We know how to calculate the area of a polygon. We multiply the length with the width, and so that's what we're going to do. The first thing we're going to do is declare another variable, and logically we're going to call that area because we are trying to calculate the area of something, and area is going to be equal to length and multiplied by the width. We use a semicolon. So we've calculated the area, and we're just going to do a simple console.writeLine just to output that console writeLine. Just putting a simple message saying that the area of our rectangle is. We're going to concatenate that to area. We can close this off with a semicolon, and I'm going to put in a quick console.readLine. Read key. Read key should be sufficient. Okay, no squiggly lines. Let's do a build. There's no errors there, so I'm just going to quickly recap on what we've done. We've created a class, and it's called rectangle. The class implements iPolygon, and because it's implementing this interface, we have to provide code for every method, every function, and every method that is contained with iPolygon. We have to provide a code for that, and we only have one method, and it's called calculate. So we provide the code for calculate area. Area is calculated using length multiplied by width, and we do a simple console.writeLine. Okay, and the very last thing, the very last class that we need to create is a class that creates an instance of rectangle so that we can use rectangle. So again, we go to interfaces, we do a right click, we do add a new item, and again it's going to be a .cs, and I'm simply going to call this interface. Okay, and I'm going to get rid of this. That. Okay, so in this class, we're going to create an instance of our rectangle class, but the very first thing we need to do is to declare our method, our main method. So it's static void main, capital M. And we do this because we know this is where the program, wrong braces, this is where all C# programs start. And within this, we can instantiate our rectangle. So in order to instantiate rectangle, we use the name of the class. We're going to name this instance, we can call it rectangle. So if I tab that, Visual Studio very helpfully puts in the word rectangle for me. If I tab again, it's going to complete that bit of code for me. So we're saying here, create an instance of rectangle, call it rectangle. No, I'm not going to call it rectangle. There's too many rectangles going around. It's going to call it rect. So we're creating an instance, we're creating an object of the class rectangle. We're giving it a name rect. We use the new keyword in order to create that instance, and then obviously we have to use the name of the class again. So now we have a reference to our rectangle, and that reference is rect. If I can get my cursor in the right place, we might be able to do something with rect. Rect. And if I use dot notation, so I type in rect dot, and then I can see all the methods that are available to me. So I want calculate area, and so I'm calling calculate area, and I know calculate area takes two parameters. Both of those are going to be integers, and rectangles tend to have a longer length and a shorter width. So let's give this a size of 300 for the length and 100 for the width. I can end this line of code by using the semicolon. I'm just going to clean this up. Cool. And so the reason we've created this class is because we've placed our starting point here, the main method. And within the main method, we have instantiated our rectangle class. We've given it a reference, and then we've used a reference in order to call the calculate area method. So let's see what this does. We are going to hit F5. Okay, hopefully you should be able to see that. The area of our rectangle is 30,000 because we multiplied 300 by 100. Obviously, we didn't specify what units. They could be 30,000 inches or centimeters or whatever, but we don't need to worry about that just yet. So these are integers. Cool. So just a quick recap again. We created an interface. we created the interface in the iPolygon.cs file. We said the interface only has the one method. It's called calculate area. Next, we created a class that we were going to use in order to implement that interface. So we called that rectangle. We used the semicolons to tell Visual Studio that we want to implement this interface, and that bound us into a contract whereby if we use an interface, we have to flesh out all its methods. We have to put code in all the methods that are associated to that interface. So we did that. There's only one calculate area, and we provided just some very simple code. And then lastly, we created the interface class. We placed our main method in there, and in the main method we were able to instantiate our rectangle class and then call any methods associated to that. As mentioned earlier in this video, a class can only inherit from one class, but classes can inherit from one or more than one interface. So the next thing we're going to do is we are going to change this program, or change this application slightly to allow this rectangle class to implement another interface. So in order to do that, we are going to create another .cs file. So we're going to do a right-click add, and we're going to create another interface, and we're going to call that interface, let's call it color. So it's going to be eye color. We add that. Visual Studio is clever enough to realize that we placed an I before the name of our interface. So it was clever enough to realize that we are trying to create an interface, and it created this interface using that keyword interface. Keep sticking this stuff in there, so it's not too clever. I'll just get rid of this. Okay, so we've got another interface, and we are going to have just one method in here again, and keep things nice and simple. And that method is going to return nothing, so it's void. And we are simply going to get the color of our rectangle. So that's it. That's all that eye color interface contains. Let me just stick in, I'll put in some comments. Okay, so we can save this. And we can go back to our rectangle class. And now in order to implement eye color, and we go to the end of this line, we place a comma, and we start typing eye color. We've got a squiggly line under eye color, and Visual Studio is complaining and saying you're going to implement this interface called eye color, but you've not provided any code for the method. So we're going to go ahead and do that. So this was iCalculate, and I can come down to here. I can do void, and the name of our method is color, get color. It doesn't take any parameters. Let me just scroll up a little. Okay, so the squiggly's gone. Visual Studio is not clever enough to realize that we haven't actually placed any code in here. but it knows that we've actually coded up the getColor method. So all I'm going to do here is put in a console.writeLine. Console.write, and we're just going to return a hard-coded value, and that's going to be, I'm going to return the color red. Let's call it a rectangle. So we are returning red rectangle text, and that's it. Okay, so the next thing we need to do is go back to our interface class, and now if we've come to here, if we type in rect dot, and now we can see the calculate area method, but we can also see the get color method, and that's the one we've just added. And that's all we need to do. It's not get colors, it's get color. That's excellent, and that's it. Let's go back to a rectangle class. In fact, let's go back to iColor. So just a recap, we wanted to use another interface. So we created that interface. We use the keyword interface. We gave our interface a name. We called it color, but we preceded the name with a capital I to signify that it's an interface. And then we provided a single method without any code in the body. Next, we went to a class that we want to use in order to implement our new interface. We're already implementing one interface, iPolygon, and now we are implementing another interface, iColor. If we choose to implement this interface, we are entering into a contract with .NET, with C# saying that I've chosen to implement this interface, so I promise to provide code for every member of this interface. We only have one member. It was called getColor, so we provided the code for that member. The last thing we did, we went to interface. Interface contains our main method. This is where all C# programs start from. We had already instantiated, we'd already created an instance of a rectangle, and we had a reference to the rectangle instance, RECT. Using RECT dot, we can see all its members. So then we called our getColor member or method. So if I do a quick F5, I should be able to see this in action. Did I actually push F5? Yes. Okay, you should be able to see rectangle is still 30,000 units in area, but it's also a red rectangle now. If I quickly go back to rectangle class, at the moment rectangle class is not subclassing, it's not implementing or inheriting from another class. But if we did choose to inherit from a class, we can only inherit from one class. And if we did choose to inherit from another class, the name of that class would have to be before that. The name of the class would have to appear before both of these. So the first thing we list is the class, and then any interfaces after that. If we choose to place the class name over here, then Visual Studio would throw an error. So in the list of implemented items, we list them from the first one would be the class, and then any interfaces after that. Okay, so that's it for this video. We covered quite a bit there, so let's have a quick recap. Obviously, the video was in regards to interfaces. We said that interfaces are similar to abstract classes. Interfaces do not store state. There's no instant variables. They only specify behavior, and we use methods and functions in order to capture that behavior. The methods and functions in an interface cannot contain code in the body. They are totally abstract. Interface methods and functions are implicitly public, so you don't have to explicitly define them as public. We can think of an interface as being similar to a contract that defines a set of methods and properties that a class must implement if it's implementing that interface. Interfaces cannot be instantiated. We cannot create an object from an interface. They have to be implemented by other classes. A class can only ever inherit from one other class. So you cannot have one class inheriting from more than one class. But a class can inherit from a class and any number of interfaces. And then we looked at some of the benefits of interfaces, and these include greater abstraction of code, more flexibility in our code, and more reusability of code. We also said that interfaces allow objects of different types to interact with each other, and this is known as polymorphism. We're not going to look at polymorphism in this series of C# videos. Hopefully going forward, I may well do a series on a more advanced C# code, and then we may well look at polymorphism in a series of videos. I hope you found this video to have been informative and helpful. If so, please do consider subscribing and hitting the like button. Thank you so much for watching. I hope to see you in the next one. Thank you very much.